Good afternoon and welcome again. In the last video, we talked about the power rule. So we said that if you're given a function f of x equals x to the power k, the f prime of x equals to k times x k minus 1. And we know this will be true for any polynomial that given. So if you were given f of x equals to x to the power of 6, your f prime of x equals to 6x 6 minus 1, which is 6x to the power of 5. Now you may be wondering what would happen if we had a chain of functions. So let's say we have f of x equals to x power 6 plus x to the power of 3 plus x to the power of 5. What you will do, you will evaluate each derivative as a separate function and then add them all together. So this will be f prime of x equals to 6 x to the power of 5 plus 3x squared plus 5x to the power of 4. I hope this makes sense. Now, before I touch on the chain rule, what would happen if you have f of x where the function is multiplied by a constant? Let's say f of x equals to 5x to the power 6. What you will do is you will take this 5, you isolate it out, times the derivative of what comes after it. So it's just going to be 6x to the power 5. So this will be 30x to the power 5. So your f prime of x equals to this. Same thing will be true. So if you have f of x equals, let's say, 10x to the power 3, your f prime of x will be equals 10, take the constant out, times 3x squared. And this equals to 30x squared. Now I think it was also very important that I mention what the derivative of a constant would be. So if I have a function, let's say I have a graph like this. So this is my x-axis, this is my y-axis. And I said f of x equals to 2. So this graph, this will look like this. We'll have y equals to 2. This is how we will graph it. It's just a straight line. Now what is the slope of this line? There's no slope. So the slope is 0. Therefore, we can say that the derivative of a constant, is 0. So if you're given f of x equals to, let's say, x squared plus 5, you will evaluate this derivative as, so f prime of x will be 2x, but this one equals to 0 because the derivative of a constant is 0. Now let's talk about the chain rule. If you have any questions, you can leave it in the comment section and I will be more than happy to answer them. So now let's say we have f of x equals to 2x plus 5 to the power of 3. This may be a little bit confusing, but let's substitute this function as x. So I'm creating another function here now. So let's say x to the power of 3. How did we evaluate this one previously using the power rule? What we did was we took the power down, 3, times the function, so 3 minus 1, right? And then, without actually knowing, we did something else. What we did, we took the derivative of the inside of the x. What's the derivative of x? It's just 1. Right? So you can see that here what we did was power down, then power minus 1 times the derivative of the inside. So let's apply that here. So we said f of x equals to 2x plus 5 to the power of 3. So the derivative would be, like I said, we're going to evaluate this as if it was one function. Right? Power down, 3 times 2x plus 5 power minus 2, right? Minus 1 rather, so 3 minus 1. Then you multiply by the derivative of the inside. What's the derivative of the inside here? So this is the power, x to the power 1, so this is 2. Right? So we'll have 3 times 2x plus 5 to the power squared multiplied by 2. Okay? So this will give us 6 2x plus 5 squared. Yes, I know from the beginning this can be a little bit confusing, but if you just use the general concept as your power rule, by treating this one as being one function, then the rest will be easy. Now let's do more examples. Hello again. As a continuation from the chain rule from the last video, I'll be kind of doing more practice problems so we can practice more together. So now let's say f of x equals to x squared plus 5 to the power of 4. If you want to evaluate this, like I said in the last video, you will treat this as if it was one function. You apply your power rule and you take the derivative of the inside. So first thing we do, f prime of x, we apply the power rule. So power down times x 4 plus 5 power minus 1, so 4 minus 1, multiplied by the derivative of the inside. You can see the derivative of this one, it is another power rule within itself. So that would be 4x cubed, derivative of a constant is 0. So f prime of x will be equals to 16, 4, x to the power 3 times x to the power 4 plus 5x cubed. Let's do another example. So f of x equals to, let's say, x to the power 6 or 2x to the power 6 plus 4 to the power of 3. Again, so f prime of x, we do power down times 2x to the power 6 plus 4 power minus 1 multiplied by the derivative of the inside. So in this case is what? 2 times 6. So 2 times 6 to the power of 5, because you're going to apply the chain rule, the power rule inside this function. We multiply by the constant 2. Right? So x to the power 6 plus the derivative of a constant is 0. Okay? So now we just have what? This will be 12 times 3, which is 36, times 2x to the power 6 plus 4 x squared, and I missed my this one, so x to the power 5. Right? So I'm just going to write it here. So it's 36 x to the power 5 times 2x to the power 6 plus 4 squared. So f prime of x. I hope this makes sense. Again, if you have any questions, you can leave it in the comment section, or if you have a particular function that you would like to want me to solve, I'll be more than happy also to do that. But again, it's all practice. The more you do these, the easier it gets. All right, thank you for watching.